Well, yes, then now I will take here insulators or bad conductors. Why the insulator like plastic, like glass, like wood do not conduct electricity? So here is the band diagram. Conduction band, valence band. In case of insulators, the conduction band and valence band are separated from each other by a forbidden energy band. This gap between valence band, conduction band and valence band is greater than 3 electron volt, maybe 5, 6, 7, 8, 9, 11 electron volt order, maybe this, but always greater than 3 electron volt. As shown in figure. As shown in figure. The valence band completely occupied by electrons. The valence band is completely occupied by electrons, means no energy level is left unoccupied. All energy levels are occupied. Here in our book, actually NCERT book show here the energy bands by allowed occupied energy band by this blue ink. They are shown here. That blue ink is there. You can see. And here all energy bands are occupied dot. So I can't, we can see only by lines. While conduction band is completely vacant. No electron is present. In normal condition of temperature, when we apply electric field across these materials, electric field cannot give energy to electrons which they need to go from valence band to conduction band. Because gap is large. I told that energy is of few electron, fraction of electron volt. So electrically alone, and hence electron cannot jump from valence band to conduction band and it remain empty, and there is no electron which can conduct electricity, and hence conduction is not possible. Hence conduction is not possible. In case of some insulators, thermalization means energy given to them in the form of heat, which make the atom oscillate with large amplitude. The movement of electron due to thermal energy given to them is called thermalization. In case of some materials thermal agitation can make electrons to jump from valence band to conduction band. Thermalization, if we heat up, then energy of electrons will increase and they can jump across the gap. That is why, this is why ionic compounds conduct electricity in their molten state. When they get melt, they can conduct electricity. Thermalization can provide this much energy. So we are differentiating here the good conductor, insulator and semiconductor on the basis of energy band. This is very important to understand here. Now I take semiconductors. Semiconductors. I told you semiconductors conductivity lies between good conductor and bad conductor. Very important thing is there in case of metals. The resistance and hence resistivity increases with the increase of temperature. In case of semiconductor, the resistivity decreases and conductivity increases with the temperature. Then how to explain? So here it is conduction band. I may write here CB only. It is valence band. Energy gap less than 3 electron volt. Remember it. Once there was a question of 3 mark in board exam. Draw the energy band diagram for metals, insulator and semiconductor. Mark the energy gap between the two bands. Happy? It is at low temperature. Low temperature. Close to 0 Kelvin. So close to 0 Kelvin, this valence band completely occupied by electrons. Valence band completely occupied by electrons, while conduction band empty. Energy gap of 3 electron volt. When we apply electric field across this at low temperature, no conduction will take place because there is no electron which can conduct. Now you will enjoy what is our aim here. Our aim is only to explain why the semiconductor conduct electricity at room temperature, not at temperature which is close to 0 Kelvin. Because at that low temperature there are no electrons in conduction band. Electric field cannot provide that much energy. But at room temperature, what happens at room temperature? Conduction band. Energy gap less than 3 electron volt. Maybe 0.5 electron volt. For silicon, it is 1.1 electron volt only. It varies. Not only it remain only 3 electron volt, less than 3. Maybe 0.5, maybe 1.1, maybe 1.2, depending on the nature of gallium, silicon and germanium are two elemental semiconductor. In silicon, the energy gap 1.1 electron volt, and germanium furthermore lower than this. So now it is valence band here at room temperature. So at room temperature, I told you thermal agitation can impart energy to electrons. Since gap is less than 3 electron volt, so some electron may jump from here. Now I create here a circle means hollow. Hollow means the electron is not present in this level, and corresponding to this there are dots here. 3 electron has gone that way. At room temperature, some electron jump from valence band to conduction band. As temperature increases, more electron will go from valence band to, but the number of electrons in conduction band again will be small, not like good conductor. In case of metals, 3 electrons are there, 10 to the power 19, 10 to the power 29 or 80, 10 to the power 18 electrons per meter cube. They are not this much. But as we increase temperature, more electron can jump from valence band to conduction band. Thereby, the electrons are present which we can conduct. So, semiconductors conduct poorly at room temperature. At room temperature. At room temperature. So how to explain figure 1, figure 2? In case of semiconductors, I am writing because when we are asked in exam, student are unable to write. Please learn all these things how to write. Read the books. Better you read book like NCRT or other book. Go thoroughly. In case of semiconductors, conduction band and valence band are separated by small energy gap, e.g. less than 3 electron volt. इलेक्ट्रॉन वोल्ट एनर्जी यूनिट ऑफ एनर्जी है एट वेरी लो टेम्परेचर वैलेंस बैंड is completely occupied by electrons and valence band, and conduction band empty, completely empty, means empty. So, and if you apply electric field, since electric field applied across semiconductors cannot impart energy to electrons which they need to go from valence band to conduction band. So, at low temperature, semiconductors behave like insulator. Completely they become insulator. But at room temperature, as shown in figure 1, at low temperature conduction band empty. Right? But at room temperature, which is taking 27 degrees centigrade, or lower than this also, but not at low temperature. Thermalization. Thermal agitation imparts energy to electrons which is greater than the energy gap between valence band and conduction band. So some electrons are found in conduction band as one electron jump from valence band to conduction band at room temperature here. A vacancy is left in the valence band. The vacancy created due to jumping of electron from valence band to conduction band is called hole. H-O-L-E, I will call it hole. These holes act as positive charge carrier. By metals, electron are the charge carrier. Here in semiconductor, electron in conduction band and holes in valence band both act as charge carrier. I write here electrons in conduction band and holes in valence band act as charge carrier. Here in this semiconductor, the number of hole and electron are equal. In pure semiconductor, conductors Ne equal to NH. Ne means number of electron per unit volume. We call electron density, and hole are equal and both conduct electricity. The number Ne and NH, now this is again per unit volume. The per unit volume increases, the number Ne and NH increases with the increase of temperature. Therefore, conductivity of semiconductors, conductivity of semiconductors increases with the increase of temperature. While in metals it is reverse. On in temperature conductivity decreases. So this was something about the differentiation between metals, insulator and semiconductors on the basis of energy bands. In first video, I gave you the differentiation on the basis of measured conductivity and resistivity. And the important thing here we get when temperature increases, conductivity of semiconductors increases. And we exploit this fact in many places. On the basis of energy band diagram, the energy gap between valence band, conduction band in case of semiconductor is less than 3 electron volt, maybe less. We can alter the energy gap between valence band, conduction band by doing something from outside. But for a pure semiconductor, the energy gap depends on the nature of semiconductor material. I hope you will like it. Please watch 2 times or 3 times. When you watch, you will get it learned. But write yourself. Yesterday I was watching a movie, 12th Fail. I got inspired, although I have struggled the same way. You have to learn again and again and have a practice of writing. Nowadays, actually, we have got different some fill up the blank, some match the following column, but there are some questions which you need to write the explanation in long essay type. Initially, in our board exam, there was a question of 5 marks. Explain the energy band formation in solids and differentiate between them on the basis of energy band diagram. 5 marks. तो पहले ऐसा थे, अभी आता है 5 मार्क, लेकिन they split further 2 marks, 3 marks, like that. So please like the video, share the video with your friends, and it will not harm you. It will give benefit to your friend. Everybody wants to help his friend. So help your friends by sharing, by explaining, by telling the things better way, and by telling the source of information. You can help your friend and motivate your friend to work hard. Thank you.